So, hi everyone, we're super excited to have you here. My name is Devshri, and just for a really brief introduction, I have a lot of experience in AI. I'm certified in AI, and I have made a lot of science fair projects and research projects in AI that have won numerous awards and cash prizes. And I'm going to be one of your instructors today, and we also have another instructor.
Hi everyone, my name is Aveen. I'm your guys' other instructor. I'm also certified in AI from the Harvard Computer Science Society. I've also made multiple of my own AI projects. We're really looking forward to teaching you guys more about Python and AI in general. And we're going to give you guys more details about ourselves and our program on our first actual class. But yeah, let's just get started with today's lesson. So today we're going to be covering three important things. We're going to be talking about how you're going to utilize Google Classroom just to do your basic maintaining of housekeeping. We're going to do an introduction to Google Colab, which is the platform that we're going to be using for most of our, actually for all of our Python coding. And then most importantly, we're going to go over all the Python basic skills and concepts that you need to know to be able to code AI. So getting started with using Google Classroom, make sure you guys are frequently checking your emails and Google Classroom to stay updated. We're going to be posting the slideshows, Google Notebooks, and video recordings of each session onto Google Classroom so that you guys can access them at any time whenever you need to review or if you can't come to a class, whenever you need to access them. And most importantly, to receive the signed certificate, you must complete and submit all of the projects and assignments on Google Classroom so that we know that you guys really got a good understanding and you guys completed everything. And we're always here to help. So if you guys ever have any questions or anything, feel free to shoot us an email and we can help you guys out.
Okay, now we are going to go into something really, really important, and that is working with Google Colab. Now, if you've never heard of Google Colab before, don't worry if you have. Also, don't worry, we're going to go in depth and explore the tool and how we're going to be using it. So, first of all, what is Google Colab? So, Colab is an online Python scratchpad. You can think of it as a place to write code. And if you're not familiar with Python, it's a programming language known for its easy readability, ease of learning, and versatility. And we are going to be teaching you that today too. So Colab is super simple to use. It's free and there's no download needed. It allows you to write code in your browser, and you can also add files to perform data analysis on, which is really, really important when it comes to AI. And finally, Colab gives you access to powerful computers to run AI code. So even if your computer is basic, it doesn't have super advanced functionality, you will still be able to run all of our code because Colab gives you access to these supercomputers, which is so, so insanely cool. But now let's get into some technical parts of Google Colab now that we've covered what it is. So for some basics, files and projects that you make in Google Colab are called notebooks. So whenever we say, oh, we've posted the notebook to Google Classroom, or please open the notebook, we're referring to a file in Google Colab. So make sure you have that in your brain. Notebooks are made of cells, or things called cells, which are boxes where you put stuff. Now, I know stuff is a really vague word, but the reason we've used that word is because there's different kinds of things you can put in cells. So, cells can be either code cells or text cells. Code cells are cells where you can write code in and run. So, those allow you to write Python, etc., and you can actually run those cells. Text cells, on the other hand, are in the name. It's used to write text. You can add notes, titles, etc. to your file to arrange your file, decorate it, do documentation of your code, etc. And you can run code cells by pressing Shift Enter on your keyboard or pressing the Run button. And I know it may seem a little bit abstract to you right now because we haven't actually started using Google Colab, but as soon as we jump in, I will show you how to add cells, what do cells look like, and how to run cells. So don't worry if this is not fully registering, but just have this idea in your brain that notebooks are made of things called cells. The last point is really, really important. And I'll say this again in case you forget. Always remember to make a copy of the notebook we provide you so you can make edits to it and it stays on your own file. So what you or your edits don't show up for everyone, but they show up for you. Okay, now, of course, we believe that best learning is through doing. So let's go ahead and explore Colab, and we are going to actually learn Python as we walk through Google Colab. So my co-instructor Aveen has just dropped a link to a notebook. So why don't everyone go ahead and just click the link that she just opened, and I'll give you a couple seconds. When you get to the link, it should look something like this. So I'll give you guys a couple seconds to open that up on your Google Chrome or whatever browser you want to use. Just go ahead. I'll give you like 30 seconds. And when you open the file, make sure you don't click anything just yet. We'll tell you exactly how to go from here after everyone has gotten here. All right. So if anyone hasn't opened the link yet, then go ahead and like you can message Aveen in the chat. She'll help you out. But for those who have, we're gonna do something really important before we get to exploring everything. If you have a button next to help that says copy to drive, go ahead and click that. So I don't have that button, but if you have that button, make sure you click copy to drive. Now, if you don't have that button, I'll show you how to do that. So for those who don't have the button, you're gonna go over here to File. So where my cursor is, you see File? You're gonna click File, and you're gonna go and click Save a Copy in Drive. So this will make a copy of this entire notebook and allow you to access and edit it. So go ahead and click that, and it should open up a new tab with your workshop. So once that is opened up, Aveen, seems like we have someone new joining in. If you could update them. Once you've opened up the notebook, we can get started and made a copy, we can get started. So the first thing we're going to do is go ahead and take a tour of the entire interface. So you're probably seeing a lot of things around this notebook. You know, there's text, there's code, there's buttons everywhere. So let's go and take a simple tour. The first thing we have to look at is up here. This is the title of your notebook. You can change it, but typically we'll already have the nice title ready for you when we send you the notebook, so you don't have to worry about that too much. Next, under that, under the title page, you'll see a bunch of tools to help you out to like go ahead and navigate Colab. Honestly, these aren't used much, so we're not gonna go into them, but in case you're curious about them, then ask us and we'll help you anytime. Let's go over the main things in Google Colab. The first thing is on the left side. So you'll see one, two, three, four, five different buttons. We're going to be going over two of these, which is really important. The first button right up here is a table of contents. Now, if you click the table of contents, you'll probably see we have 8 sections of Python ready for you. But this is important for you if you want to navigate the workbook or navigate the notebook, then go ahead and click table of contents and you can actually navigate from here for ease of navigation. If you go down here to the last button, it's called Files, you'll notice that it says you can add files, etc. later. We're not going to be using it right now, but just for the future, you can go ahead and add files. So don't worry about this now. We'll go over this later more in detail, but yeah, just know that you can add files. So I hope everyone has made a copy and not on the same notebook. So just hopefully everyone has made a copy on their respective notebooks. But now we're gonna go ahead and show you how to add cells. So if you notice, on the notebook, we have cells that look like this, or lines that look like this, and lines that look like this. So you'll notice that they look different. The code cells have a different gray background, while the text cells are just lines of text. So you're probably wondering how you actually add those. And the way you do that is you go up here next to commands, there's a thing called plus code and plus text. And you can go ahead and click those to add cells. So if you can go ahead and click them if you want, you'll probably see cells pop up on your notebook. And when cells pop up on your notebook, you know you've done it right. So go ahead, you can experiment with that. Um, but after you've made your cells, just go ahead and delete it by clicking the cell and clicking delete. So I'll give everyone a bit of time if you guys want to experiment with cells, but really we'll be working with them later today. Does anyone have any questions about Google Colab so far? If you think I'm going too fast or too slow, make sure you let us know in the chat because I will be checking. All right, no questions. Is everyone caught up? I am willing to wait a little bit. For those who are new, make sure you have went in and created a copy of your notebook. Aveen, we're getting new students as we speak, so make sure you keep updating them as well. Alrighty, so seems like we don't see anything. Okay, so it's some people's first time using Google Colab. No worries, we'll go slow. It'll be really easy to get started. Now let's get into the actual Python part, and we're actually going to start using Google Colab as we do this. So remember, this recording will always be posted for you if you ever need to catch up. We're going to go section by section, cover Python, and you'll be able to work with Google Colab as we do this, so it's a great system. We're going to start with section 1, which is printing. So, for those who are unfamiliar with print, print is an example of a function, which is essentially something that executes a task. So, a function in Python is something that performs a task. Now, some functions are actually given to us already in the code, and some functions we can make. Print is a kind of function that's already given to us, so you don't have to worry about coding how to print. That's a function that you can use anytime, anywhere. So the specific task that the print function executes is displaying and outputting any text that you give it. So if I print something, it'll show up on my screen. So it's as simple as that. It's really, really important to visualize what is happening in your program. So let's say you want to check if a line of code was ever run. You might put a print statement after that line that says code was run. There's many other uses for print statements that you'll see as we go through the course, but we're going to start working with basic print statements just to start. So if you look right here in the code cell, that is an example of a print function. So it says print hello world. You can go ahead and run this code by pressing the play button on the text cell. So it looks like this. I'll keep my cursor there for a second so everyone can see that. Go ahead and press play. If it says that you have too many sessions, don't worry. We'll fix that a little later. But just know you can look at my screen that hello world will indeed be outputted. So now it's your turn. So go ahead, write the word print and open parentheses, followed by whatever you want to output in quotes beneath in between the parentheses like this. Insert your quote here. So go ahead, write the word print, create a set of parentheses, create a set of quotes, and go ahead and input whatever text you want inside the print statement. I will give you guys a solution to this in just a couple seconds, but I'll give you guys time to go ahead and try this out yourself. Okay, hopefully everyone tried it out. I'll print an example right here. So let's say I want to print youth x AI. This code right here would go ahead and print youth x AI to my screen. Um, Super simple, super easy. Yeah. Next, we have to make sure that we understand that if you guys are getting the error that it says that we have too many sessions, we'll work on fixing that a little bit later. But just for now, if your code looks something like this, it will run. Now I'm going to pass it over to Aveen, my co-instructor, to go over section 2 with you guys, which is arithmetic operators.
Okay, so now that we know how to print things in Python, another really important thing that we need to know is about math. So Python can handle all of the basic arithmetic operations just like a calculator, but can also go even further. Arithmetic operators, I know they may seem simple, it's just simple math, but truly they really are the foundation of AI and what it does. I'm sure we all know about addition, subtraction, multiplication, and division. So we're just gonna look at this first cell. If we run it, we have four different print statements. We just talked about print statements, and in between all of them, we have a different operation. So in the first one, we have addition, 5 plus 3. If we look down into the output, we see it outputs 8. Same thing for the second one, it's just 10 minus 4. We look at the output, it outputs 6. For multiplication, 6 times 7, it outputs 42. And 25 divided by 4, it outputs 4. One important thing we want to note, though, is when we look at division, even though it's outputting a whole number, we still get 4.0. So whenever you do division, no matter what, it's going to output a float data type. We'll get into more detail about different data types and what that is in the following section, but just keep that in mind. And so looking at other operations, we have exponent. Exponent just raises a number to the power of another number. So we have our examples here. If we run the cell, we have 2 to the power of 3 is equal to 8, and then 5 to the power of 2 is equal to 25. So when you run it, it just prints out the output. And then our next operation is modulo. So modulo, what it does, it just gives the remainder of a division. So think, if I divide the number, what's left over? I know this one may seem a little bit new to you guys, but it's really simple to understand. So if we look at our examples, our first example is 10 modulo 3. It outputs 1 because 10 divided by 3 is 3 with the remainder of 1. In our second example, we have 25 modulo 4, which outputs 1 because 25 divided by 4 is 6 with the remainder of 1. And then our last example is 8 modulo 2, which outputs 0 because 8 is divided evenly by 2. And then our last arithmetic operation that's important for us to know is floor division. Floor division divides numbers but rounds it to the nearest whole number, which basically it just leaves off the decimal part after dividing. Think, how many times does a number fit completely? Um, so in our examples here, we have 10 floor division 3, it outputs 3 because 3 fits completely into 10 3 times. Our second example, 25 floor division 4, outputs 6 because 4 fits completely into 25 6 times. And then with our last example, it simply outputs 4 because 8 divided by 2 is 4 evenly. And yeah, so that's all we need to know for arithmetic operations. Now we're going to get more into variables, and Def, going to go over that.
Yeah, and I just checked the chat. It seems like we have a great question. So the question asked was, are the hashtags part of the code? That's a great question, and the answer is no. The hashtags are not part of the code. The hashtags are something used to denote or used to create comments. So comments are basically things, lines in code, text in code that allows you to clarify things or that allows you to give any extra information about a line of code. So let's say you write a line of code and you want to explain what the line of code does, you can add a hashtag and then write a little explanation that can be for yourself, that can be for someone else reading your code. The hashtags are just there to indicate a comment. So anything after the hashtag in the green color is not getting run. So hopefully that cleared that up. And Jack, you just keep asking questions like those. Those are great questions. Keep them coming. Um, Hopefully everyone understood arithmetic operators. Like Aveen said, they're really the foundation of AI. We use them a lot to manipulate data, store data properly, etc. But now we're gonna go into something arguably even more important for AI especially, which is something called variables. So variables are like labeled boxes that store information. So think about that for a second. You can store any piece of information you want in like a little box, and that box is called a variable. You can store anything from numbers, words, lists of different things. We'll get into that in a little bit. But it's really, really useful for us because we often need to keep track of certain pieces of information in order to run our code properly. So, just as an example, we might want to save someone's name and age in a program that wants to remember a user's name and age for the future. So, that is just an example of AI. Let's learn example of a variable. Let's learn how you can exactly make a variable in Python. So you know what it is now. Let's learn how to actually write a code for it. So the way to define a variable is to first start by creating a name for your variable. So make sure it has no spaces, doesn't start with a number, it's only letters, numbers, and underscores. The next step is to write an equal sign. This basically tells the variable what it's going to be assigned to, or what value is going to be put in the box. That's the variable. And the third step is to finally write the value that you want to put inside the variable. So what value do you want to put inside the box is the thing you put after the equal sign. So if you want a visualization of that, look at the code cell right under the text cell. See, name is equal to youthxai. Name is the name of the variable. The equal sign tells the variable what it's going to be assigned to, and the value youthxai is what is being stored in the variable. We also have another variable right after name. We have the variable age. So the variable age is also the name of the variable and is equal to the number 1. So as you can see, when we've printed both of the name and age, it outputs youthxai and 1. We didn't have to go and say print youthxai. We didn't have to say print 1. We were able to go ahead and reference the variable name to get those values and actually put them in our output. So it's a really important concept to understand. You can reference variables and pull their values through their names. So in case your code is unable to run because there are too many sessions, we will work on fixing that. Check out my screen here. It has the output ready. It says UTXAI and 1. Now, did you notice something interesting? If you have a good eye, you probably saw something. The way we wrote the number 1 and the way we wrote youth XAI looks completely different. You are probably thinking, why in the world does youth XAI have quotes around it? And why does the number 1 not have anything around it? Like, why did we just write the number 1? Well, the answer is because these are two different types of information. Name is a text or a series of characters written in quotes, and age is a number without quotes. This is something called data types. These different kinds of information in Python or any coding language is called data types. Variables can hold many types of data. Here are a list of really common data types that we will be seeing. Strings is the first kind of data type. It's text or characters that are inside quotes. So like hello inside quotes, 1, 2, 3, 4 inside quotes. Think of string is a series of characters, okay? Second is integers. Integers are whole numbers, numbers that don't have decimals. So it's like number 1, -2, 99. Those are examples of integer data types. Third kind is floats. Floats are basically integers, but they have decimals. So 1.0, 2.7, -2.7, 66.7. And finally, we have booleans, which represent true or false values. So if you're a little bit confused, don't worry, we'll go over each of them right now. So let's start with string, a piece of text. Take a look at the variable name is equal to Bob. Bob is an example of a string because it's in quotation marks. Do you see that? It's in quotation marks, which makes it a string because it's a series of characters. So name is equal to a string value Bob. Second, we have integer, a whole number. Age is equal to 16. 16 is a whole number, it doesn't have a decimal point, etc. It's a number, it doesn't have quotes, so it's an integer. Third, we have float value, which is a decimal number. Height is equal to 5.8. See, notice we have the 0.8, makes it a float. And we have the Boolean value. For example, the variable is called isStudent, so it might be checking, is this person a student? And the answer is true. You'll notice that when you write true, the color changes, which shows that it is a Boolean value. So you're probably it might be a little bit confusing because we actually haven't started using things yet, but don't worry, this will get familiar as we actually start doing exercises. So data types tell Python, you're probably wondering why do data types even matter? Well, the answer is data types tell Python what kind of information a variable holds, so it knows how to use it correctly. Python is as smart as we've made it, so it doesn't know it automatically what kind of data type the variable is. You do have to make sure you tell it. So by doing the proper syntax or grammar, you can basically tell Python what kind of data type it is. So when we put quotes, Python will be like, oh, it's a string. When we don't put quotes, it knows that it's something else, like an integer, Boolean, etc. So take a look here. We're here kind of combining arithmetic that Aveen taught and variables right here. So you see here, take a look at this text cell right here. Height 1 is equal to 2, an integer. Height 2 is equal to 3, another integer. So we have two heights here being stored in variables. Total height is equal to height 1 plus height 2. So what this variable is equal to is the sum or the total of the two variables that we've made before. So you've probably seen an intersection, right? We're able to perform arithmetic operations with variables, which is actually really, really cool. So take a second, don't run the code. What do you guys think total height is going to be equal to? Just think in your brains. So if you said the answer is 5, then you're right. You'll notice here that when we've printed total height, we've gotten the output 5. So just know that you can do arithmetic operations with um with variables. So here's an exercise for you guys to try it out. Go ahead, enter your name under next to the name variable and enter your age next to the age variable and print out both your name and age. So I'll give you guys some time to go ahead and attempt that. Meanwhile, we'll go ahead and answer some questions that we have in the chat. So if you don't have a question, keep going. Try out this exercise. If it doesn't let you run, we will go ahead and fix that. But just let us know once you've finished, and we'll go ahead and get to answering some questions. Okay, so I gave you guys some time. Don't worry if you are falling behind. There will be plenty of time to catch up. You can always ask us questions after class as well. So let's take a look at a solution example right here. So my name is Devshri. So what I would have done is put in the text Devshri right here. So you can see my solution over here. If you guys look at my screen, name is equal to Devshri. So if your name is, for example, Sarah, you can change out Devshri for Sarah. Whatever your name is, you can put it and it will work. So you can always change the value of variables. So when you make a variable, its value is not fixed in stone. You can always change it. So one thing to make sure is that the value of name has to have been in quotes. So make sure it's in quotes because it's something called a string data type. String data types are a series of characters or text. So that we need to make sure we're in quotes so Python knows that it's a string and knows how to use it. Second, we have age. So for example, let's say you're 20 years old, for example. You can put age is equal to 20, the integer 20, and it will work. Now, if you have to print both your name and age, super simple. Go ahead and print name and print age, and this should work and output your name and your age. If you're unable to run it, again, we will fix that problem a little later. You can always run it on your own time, but just know that it will print the name, your name, and whatever age you put. So always know that variable names can be updated, and there's no fixed name that variables have to be. Now, we're going to go through a little bit of a coding exercise, which will incorporate everything what we've learned a bit. So if you've been paying attention, you will be able to successfully complete this. And if you still need help, go ahead. Obviously, the chat is open for you guys. So let's go over this coding exercise together. In this exercise, you will use variables and math operations to calculate the average of several test scores. So let's say we want to calculate the grade. We're basically doing that in code. The first step is to create variables for each test score. Some example variable names are score 1, score 2, score 3. Add all the scores together and store the result in its own variable. So that means make a variable called total scores and add and store the sum of all three scores prior in that variable. Next, create a variable for the number of tests. So basically the number of scores, how many scores you have, and calculate the average by dividing the total score by the number of tests. So basically this exercise, you're making a bunch of variables and you're using math to go ahead and calculate the average. Finally, print out the average score. So I'll give you guys a chance to attempt that yourself. If you need help, don't worry. I will go ahead and solve this in just a bit and show you guys the right answer. But you're also free to go in the chat and post whatever questions you have or if you need guidance. So yeah, go ahead and attempt that. If some instructions are unclear or anything, go ahead. Also, feel free to scroll up on the notebook and reference the previous sections if you forgot how to do something, or also feel free to ask. We will tell you. Okay, so I hope that was enough time for everyone. If not, go ahead and always attempt this on your own time. But now, if you guys can look at my screen as I go ahead and solve this problem for everyone, it would be great. So the first step is to create variables for each test score, and we have to use at least three different test scores. So we have some example variable names that we're actually going to use: score 1, score 2, score 3. So I'm going to start by making three variables. And you can give it any test score you want. So I'm going to just give it a variety of test scores. So 70%, 90%, and maybe like 80%. Next step is to go ahead and calculate the number or the total of these three scores. So we're going to do total score is equal to score 1 plus score 2 plus score 3. So go ahead and take a look at that. Check your solution, check against mine. This is how you get the total score or the sum of all three scores. We're going to again make a variable for the number of tests, and that is going to be always going to be equal to 3 in this case because we have three scores. So that means there were three exams, three tests taken. Finally, we're going to calculate the average. So if you're not familiar with the formula for calculating the average of something is, the formula is adding all the values up and dividing it by the number of values. So we've done exactly that. We've added the number, all the values up, and we've also found the number of values or the number of tests. So all we're going to do is type average score is equal to total score divided by number of tests. Now, average score is going to be equal to the average of all three scores you give it. If you need to print this, go ahead and print out average score just like this. Check your solution, check against mine, see how they compare. And then later, when less sessions are being run, go ahead and click run, and it will go ahead and output the score for everyone. So go ahead. I'll give you guys like 10 seconds to check. As you can see, I just ran my code, and the average of all my scores is actually 80. So see if you guys can run your code too. You can always press Shift Enter while you're in the code cell, or press the play button that's right next to the code cell. So go ahead and try that out. See if it works. In case it says too many sessions, don't worry. We will find a way to fix that for you. All right, hopefully as everyone has gotten a good idea of how to use variables with arithmetic operators, how to use print. As you can see, if you were able to successfully complete this experiment or this project, or even successfully understand what's happening, then that means that you are good to go with what prints are, with what variables are, with what arithmetic is. So great job, everyone. Now I'm going to pass it over to Avid as we continue learning more Python.
Okay, so in our next section, we're going to be discussing lists. This is also similarly related to variables because a list is basically like a box where you can store multiple items at once in a specific order. For variables, we were just storing one value, but for lists, now we can store multiple. Think of it like a shopping list or like a music playlist. It's very similar. And each item in the list can be a number, a word, a variable, or even another list itself. And some of the methods that we can use to manipulate lists is you can access the list values, you can add list values, and then you can loop through them really easily. To create your own list, all you have to do is so first you pick a descriptive name, just like with the variable, it's the same naming conditions. Then you just write an equal sign, and then you use square brackets, and inside of those square brackets is where you're going to store the values of the list. For example, we're creating a list here called fruits. So we named the list fruits, and then we do an equal to sign, and then inside of the brackets, we see it's the list of fruits is apples, bananas, and oranges. Around each of those values, just like Devshi was talking about, we see there's quotation marks because it's a string data type. And to see what the contents of the list are, all we have to do is print it out. And once you run the code cell, you can see that it prints out the values apple, banana, and orange. And since it's printing just directly the list, we also have the brackets and the quotation marks still around them. I'll give you guys a second to run that. And once again, just lists are really important in AI because they let us store and organize large amounts of data like numbers, images, and text that the AI uses that to like learn and make predictions. So next, to access the items in a list, we have to use an index. So think of a list like a row of lockers, and each locker has its own number. So an index, when we refer to an index, we're basically just talking about the position number of the item in a list. It's really important to note that Python starts counting at 0, not 1. So if you're looking at the first value in a list, the index is going to be 0. If you're looking at the second value in a list, the index is going to be 1. And to grab a specific item from the list, we use square brackets with the index number inside. So if we look at this code cell, we have our same list is fruits is equal to apple, banana, and orange. And to access the first item in the list, all you have to do is print and then the square brackets and then the index value inside. And since we want to access the first value, we're going to be using the index 0. And then for the second example, to print this third item in the list, we're going to be using the index value of 2 because it's 0, 1, and 2 for counting with the index. So when we run it, we can see that it outputs apple and orange. I'll give you guys a second to run that. And if you guys have any questions, just please keep dropping them in the chat. So if I'm moving too quickly, also let me know too. But we kind of want you guys to do an example now to create your very own list. Just create a list of 3 to 5 of your favorite movies and then simply just print out the first movie and then the last movie. So when you're defining your list, you just choose a name like anything like favorite movies, and then equal to, and then square brackets. And then in between those square brackets, you can put in the list of whatever movies you like. And then simply like looking back at the example we were just talking about accessing the value using its index, all you have to do is print out the first movie and the last movie using those index values. So I'll give you guys a second to do that. Okay, hopefully you guys were able to do that and then run the cell to see that it outputs your first movie and your last movie. Yeah, so all you have to do is just like Dashri's writing the code right now, you're creating your list, favorite movies, and then in between the brackets, you're just inputting like 3 to 5 of your favorite movies. And then since they're all strings, we have to remember to use quotation marks around them. And then each item of the list is separated by a comma. Now we're just outputting those first and last values using the index values. So as we can see, when we run it for our first one, print movies, and then the index of 0, it's printing out the first value because when we start counting at 0. And then for our second output, favorite movies with the index of 3, it's printing out the last value because we're counting 0, 1, 2, and then 3. And then you may be wondering, how do we modify lists? So to modify lists, we use an inbuilt function called append. Append lets you add new items to the end of the list. It changes the list directly, so there's no need to make a completely new one. And you can only add one item at a time. So if we look at our code cell here, we have our original list is just being reprinted. We're just using the same fruits. And if we look at the output, so if you run the cell and then you look at the output, we have original list is equal to apple, banana, and orange. Now, to add a new fruit to the end of the list, you just write the list name, which is fruits, and then dot append, and then you have parentheses, and in between those parentheses, you just add whatever value you want to add to the end of the list. So in our example, we want to add another fruit. We're going to be adding grape, which is another string value, so we still have to keep the quotation marks around it. And then once we do that, we want to just print it out to see what the updated list is. And if you look at the output, we see the updated list is equal to apple, banana, orange, and grape. So I'll give you guys a second to look at that. If you have any questions, let me know. Just drop it in the chat. And then once you guys do that, we have another exercise that you guys can do. Is simply just create your own list about like 3 to 5 of your favorite snacks, just like we did with the movies. You just define the list is equal to I did not really get the append part. We can go back and look at that. Simply all you're doing is just an inbuilt function. So it's an inbuilt function. So basically, instead of like having to redefine a list, so you have your first list is fruit is equal to apple, banana, and orange. Instead of having to write a list like another list, like and redefining all the values being apple, banana, orange, and grape, append just makes it's like a shortcut that just adds the value to the end of the list. Like, so just looking back at our example here, we have fruits dot append, and then we're adding grape. And then if you look at the output, the first original list is just the 3 values. And then once we append, we're adding the other value onto it. And it's just being added to the end of the list. It's pretty simple. Like, and you can add whatever value you want to. It doesn't just have to be a string. You can add a numeric value as well. But we don't have to get into that. That's like a little more complicated. But
Put it simply, just think of appending as adding. So append is equal to add. So we've made a list and you want to add something, just do append. Append is the same word for add. So if that makes it a little easier, you want to add something to a list. Like let's say you were making a grocery list and you're about to go to the store, but you open up the fridge and you're missing eggs. Now, what would you do? You would add eggs to your grocery list, right? So similarly, same thing we're doing here. When we want to add something to our list, we do append. So let's say we forgot our eggs in our grocery list, we would append eggs or add eggs to our grocery list. So I hope that puts it in a little bit of an easier example or a way to see it.
thank you so much, Darcy.
Yeah. Okay, now you guys should go get back to your coding
Okay,
exercise.
yeah. So now we're going to get back to the coding exercise where you're just going to simply create a list of 3 to 5 of your favorite snacks, just like we did with the other example with the movies. You're just going to name it whatever you want, like favorite snacks or whatever, and then it's equal to, and then in the brackets, you're just inputting whatever those 3 to 5 of your favorite snack values are, and they're all strings. So you're going to have quotation marks around them and then separated by a comma. Yeah, so those are our values. And then just to keep track and compare what we have as the original list, and then once we append it, first we're just gonna print out favorite snacks just as it is right now. So you guys can look back at it afterwards. And then so once we have that, that's the original statement. Now we just simply use the append function, the same thing, we're just adding it on. So favorite snacks dot append, and then in parentheses, just adding on whatever snack that you want to add to the list. It's going to be added to the end, and the index will increase. And then we're just going to print it out again just to see what the, oh yeah, now we're going to append on another value, just so we're going to append on two. And then now we're just gonna print it out to see what the list looks like now that we've added on candy and water to the end. And so when we run it, we can see that the list from the original list is Cheetos, chips, popcorn, and bread. And then once we've updated it, it's Cheetos, chips, popcorn, bread, candy, and water. The index has also increased. So first, originally it was four values, now it's six, but it's still always starting at zero. But if you need to access candy or water, you simply just count it. So it's like starting at zero, zero, one, two, three, four, five. So candy would be index of four, and then water would be an index of five. And yeah, that's basically just list. If you guys have any more questions, just let me know.
Yeah, so I saw a couple questions in the chat. We can just address them now. One person asked a great question. Why does the index increase when we add variables to a list or add values to a list? When we append or add, the index increases because we are adding more values now. So the index is basically based on how long the list is or how many things are in the list. So when there's more things in the list, the index has to get bigger because let's say you want to get the last item of the list, then you have to put a higher index to get that last item. So hopefully that makes sense. And hopefully append is also clear to everyone now. Just think of append as add. Now we are going to go ahead and explore loops. So, loops are a very important concept in all coding languages. So, there are many, 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 many kinds of loops actually. If you don't know what a loop is, it's something that repeats. It's something that repeats code that you give it. We're going to be specifically talking about for loops today because that's pretty much one of the most important ones that we use in AI specifically to go through lists, to go and print out things repeatedly. It's really useful. And you'll see the application as we start to make AI programs in a bit. But what loops do is it lets you repeat code automatically instead of writing it many, many times. Imagine I asked you to make a countdown. Like, let's say I want you to make me a countdown that goes 5, 4, 3, 2, 1, Happy New Year, something like that. Then it would be a pain to go ahead and write print 5, print 4, print 3, print 2, print 1, print Happy New Year. Instead, we can do a loop to go through a set of numbers and print each one in that set of numbers. So I know that may sound a little confusing. Don't worry if you don't get it yet. I will explain it in easier terms in just a second. But a couple things to note is that you can go through lists, you can go through a range of numbers, but what I mean by go through is you can go ahead and check each one and print something out according to where you're at in that set of numbers or where you're at in that list. So if that doesn't make sense, let's go ahead and explore a real life example so that helps you understand things a bit. Let's take a look at this code cell right here. We see the output right under it. But let's take a look at what it does. Seems like it's counting up to the number 3. So it says this is iteration number 0, iteration number 1, iteration number 2, iteration number 3. Iteration number means like how many times it's gone through the loop. Like if it's gone through the loop once, it's iterated through the loop one time. If it's gone through it twice, then it's done it twice. So what this function is doing, or what this loop is doing rather, is it's printing the number, or it's basically doing a count up. So it's counting up. Let's take a look at the structure of this. So if you look down here, it has basic pattern. So it starts with for I in range. So for is basically how you make a for loop. So when you write for, Python knows that you're making a for loop. I is an example of a variable that will keep track of the value as the loop goes through. So I can be any name actually. You can call it for UTXAI in range, you can call it for X in range, you can call it for D in range. It's just a variable that keeps track of what is going on in the loop. In range N. Let's take a look at what that part means. That's kind of the confusing part. So let's go through it and dissect it thoroughly. What range does is it gives a for loop a list of values to go through every time the loop does an iteration or every time the loop runs. So for example, in our previous example up here for I in range 4, what I will do is go through range 0, 1, 2, 3, and stop before it hits 4. So what it will do here is for I in range 4, it'll do it 4 times. This is iteration number I. Don't worry about this str thing yet, but just look at that we're printing out I. So think of range as how many times you want it to go through. So like if you let's say if you guys are familiar with repeat or anything like that, like repeat 5 times, repeat 4 times, that is essentially what range is. But it's a little bit different in the way that you can access what repeat value you're on through something like I. So for example, this is the second time I've repeated, it's gonna print out the number 1. So this is iteration number 1, the second time it goes through. And you're probably like, wait, shouldn't it print out the number 2? If it's the second iteration and we're printing out what iteration or what repeat it's on, why isn't it printing out 2, right? That's kind of confusing. Well, the answer is because whatever value you put in this range is not included in the repeats. So if I say range 4, it's gonna start at 0 and go up till 3, but it's never gonna hit the number 4. So just know, like if I put, for example, range 5, if you guys look, I just changed this over here and I pressed run. Look at that. It prints up to 4. If I do a crazy, crazy number, like maybe like 20, and I press run, look at that. It goes all the way up to 19, but it doesn't hit 20. That's because it starts at 0, not 1. So what you need to know, here's what you need to know in a one sentence. For loops basically let you repeat blocks of code for a designated number of times, which you give it through range. So in range, you tell it how many times you want it to repeat. So think of range as a repeat value. So if you don't understand what STRI means, I'll quickly explain it, but just know that it's not that important in this case. STR basically turns I, which is an integer data type, into a string. So when you want to add two strings together, you have to make sure they're both strings. Don't worry about that now, it's not really important. For example, if I just do print I, Aeneas, if that's your name, if I just do print I and I run the code, it'll give me my numbers. Like it will work without str. str is only to make sure it turns into a string when we want to add it to another string. So I would be an integer in a normal case because it would be I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. So just think of that. Um, I will just keep changing based on what repeat value it is. So does anyone have any questions? I know this concept can be a little bit confusing. Okay, great. If you still have questions, always feel free to explore the notebook a bit more. It has a lot of more descriptions for you guys to read through. But we have a couple of explanations down here. I in range loop repeats a code separate specific number of times. In the range function, so the range thing, you put a number in place of n to tell it how many times you want to repeat. Just think of that. So it starts at 0 and it ends at one value before the number you give it. Just know that much. That's good enough to know for now. So here's a basic pattern for you guys. For I in range, in n, you put how many times you want it to repeat, and you put whatever code you want to repeat in there. So when I use I, when typically you want to update what you're printing every time you're changing it, right? You don't want to print the same. Let's say I do for I in range n print high. It's just gonna print a high bunch of times. But you typically want to increase the number or something in the code. That's why we use I, because I or whatever value you put there for x in range, for youth xi in range, that variable after 4 will change its value depending on how many times the loop has been repeated. So that's the second thing to know. The value of the variable after 4, I in this case, will change based on the number of times we have gone through the loop. So the loop will keep going until the number of times you told it to run is over. So we also have a different kind of format. So this one is like a range, right? So you gave it how many times you need to repeat, and it'll repeat however many times you gave it. We have one more format, which has to do with lists, which is what you guys just learned from Aveen. So for loops also let us go through items in lists. So take a look at this code, for example. It'll make a little bit more sense after I explain it. We have a list right here, right? Fruits. If you forgot, lists are made by these square brackets right here. So whenever you see square brackets, that's a list, okay? We have a list of fruits, apple, banana, and orange. What if I want to print everything in this loop? How would you do that? I want to print every item in this loop individually. The answer to that is by using a for loop. So what the for loop does is it does for fruit in fruits. So this is a variable. I can make it I can make it x, but we're just going to make it fruit for now. For every fruit that's in the list fruits, print that fruit. That's a basic English translation. For every fruit in that list of fruits, print that fruit. So for example, when I run this code, apple, banana, and orange are all printed out. So in English, think of it for every fruit in this list of fruits, print that fruit. And it repeats, okay? So here's a basic pattern for you to reference in case you forgot. We're gonna make a quick exercise so you guys can apply this knowledge. Let me know if I'm going too slow or too fast. But go ahead and try out the coding practice. You're going to create a list of your top 5 favorite animals and use a for loop to go through that loop and print out each animal name separately on its own line. So it's kind of like the fruit example we just did. Just go ahead, give it a shot, and make sure you run it to see if it works. I'll give you guys some time and I'll show you guys the solution. While you guys work through it, I'll answer some questions. So Bhargavi had a good question. The iteration command in the loops. So let's start with what iteration means, okay? Iteration is basically the number of times you've repeated the loop. So loops go over and over and over again, right? Because it's a loop, it keeps going. But it ends at the moment you tell it to end. So let's say we told the loop to keep going until it's repeated 10 times, right? It will end after it's repeated 10 times. An iteration is what number of repeat it's on. So when I have a loop, a repeat loop or for loop that's supposed to run 10 times, if it's on its fifth time running, we say that it's on its fifth iteration. That's what iteration means. If a loop has run 5 times, it's on its fifth iteration. If a for loop has run 2 times, it's on its second iteration, iteration number 2. So iteration is just a way to understand how many times basically your loop has run. Hopefully that cleared things up. I'll give you guys like 10 more seconds to work on the list or for loop. Okay, great. Okay, we'll go through the answer now. So the answer would be you would first start by making your list of favorite animals. So go ahead, write the name of your list, press equal, and just make a list with brackets and go ahead and add your favorite animals. So my favorite animals are dogs, penguins, cats, whatever you guys like. After you've made that list, we're gonna go through the list and print every animal. So the way we do that is for animal in favorite animals, print animal. So I know it's a lot of animals, 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 but just think of it like this. For every animal that's in the list, call his favorite animals, print that animal. Let's see if this works. Click the run button, and you can see it prints dogs, penguins, and cats. So however many, items I have in this list, it'll go through the list and print it out. Because we're telling it to print every item in the list. So just think of it like that. Okay, I'll give you guys like 5 seconds to compare against that, and we're gonna move on to functions. All right, throwing it over to Aveen.
Okay, so for our next section on functions, functions are basically they're like little machines. So like you give them instructions once and then you can use it over and over again. So they keep code like really more organized and less repetitive. If we look back at the beginning of this coding notebook, we were talking about print. Print is a built-in Python function that we can use whenever we need to repeat the task of outputting a value. And you might be wondering, how should we create our own functions? So in our example here, we have def print function one prints hello world. So when we run it, it just outputs hello world. This is really like useful because instead of having to retype the print statement over and over again whenever you want to output hello world, all you have to do is simply call the function in the main of the program. To make your own function, all you have to do is so you put def, so the syntax is starting with def, which is short for define, and then the function name, open and close parentheses, a colon, and then inside of the function, after you indent, you just put whatever code that you want to repeat in the function. And once you have the code inside, all you have to do is remember to run the function in the main so that it will actually like output what you want it to do or whatever function you need it to do. So you can be defining a function like way up in your program, but as long as you're like calling it whenever you need it to run that certain task, it will work. Um, yeah, so um, yeah, always start with just like we were talking about. And yeah, so moving on, functions with parameters. So just like we were talking about, functions are like machines. When you input something into the function, so when we add parameters, we're basically just giving a function inputs to make it more flexible and useful. Instead of always doing the same thing, parameters let us change the details of the function without having to rewrite the whole thing. Like parameters are basically just placeholders. So you can give a function like different inputs. It makes it more flexible. It lets the function work with different values. So in our example here, we have the function about me. So we're defining it, and our two parameters that we have are name and age. They're both placeholders. So when we look at our actual code in the function, we're printing out a statement, my name is name, and I am age years old. So when you're calling that function in the main, you can input whatever values you want to be outputted, like to be used in that print statement. So when we're calling it, for our example here, we have about me is for name, we have the value of youth x AI, and for age, we have one. So when we run the code, it outputs my name. So when we run the code, it outputs my name is youth x AI, and I am 1 years old. But for you guys, you can test it out with like, you can put any values you want for name and age, and it will use the same values. It will use it in the function to output those like different things. It's super important in AI too because the functions with parameters let us pass different data like images, sentences, and numbers, and we process those different like data points. So I'll give you guys a second to test that out with different values so you can see how we can manipulate it using the different parameters.
I think this is a great place to see how variables are used to manipulate data. Like here, you can see clearly when you change the values you call the function with, it gets up the variables or the parameters, which are variables, get updated and used in the function. So that's just a great example of how variables are used in code.
Yeah, so hopefully you guys got a chance to run that. And now we can do an example. You guys can code it yourselves. Is you're just going to define your own function. We can call it score average. It's basically just like we did an example like this earlier. We were just like solving for the average. So you're going to have, and we're using parameters in this one too. So we're going to have three different parameters, score one, score two, and score three. And then using those mathematical operators for earlier, we know how to solve an average. You're going to create your own variable for total, and you're just adding all of those score values. We're relating it back to those like variables that we talked about using too. And then once you add those score values, you just divide it by 3, and then you can print out the average score. And so once you have that, you just have to call the function too. And when you're calling the function in the main, you can input whatever values for those parameters. So when you're calling it, it will output it based on those numbers that you input to like replace the values of those variables score one, score two, and score three. Yeah, so feel free to look back at that exercise we did earlier with solving the average. It's basically the same thing. This time we're just putting it inside of a function, so you can call it whenever you need to. It makes it a lot easier, and you can input different values for those parameters. You can use it with like, instead of just being stuck with using 70, 80, and 90 for those score values, you can put it whenever you want, and the function will run and do the same action.
We had a good question if parameters are the same thing as variables. And the answer is yes. So parameters is a kind of variable, except they do something pretty cool. So whenever we put variables inside functions, and when we've made them such that we can go ahead and call the function and input different values, and it gets thrown into the function, that is when a variable is a parameter. Don't worry if computer languages are confusing. I know I've been through that. We've all been through that. We can always help you after class as well if you guys need help. But just know a parameter is a kind of variable that you put inside a function. That you put after you see when you're doing this define statement, the variables, name and age, they're still variables. But we call them parameters just because of where they are. So because they're inside the function right here, and we can go ahead and pass whatever values or input whatever values we want to it for it and put it in the function. That's when it's called a parameter.
Yeah, hopefully you guys got a chance to like work on this exercise now too. And so we're just gonna like type it out now too. So we're defining the function score average. And then so in those parentheses, when you're defining it at the header, that's where you're adding those parameters. That's where you're adding those variables. So then you can use them on later in the function. Because then we can see the correlation between when you're in the header, when you're defining the name of the function, and then when you're calling the function later on, it's basically the same structure, except instead of having those parameters, you're replacing those with like actual values that you want to use in the function. Now we're doing the same thing we did earlier, just solving for the average. Total score is equal to score 1 plus score 2 plus score 3. And then the number of tests, we know it's 3. And then just to find the average, just divide the total score by the number of tests. And then just to see an output, we're just going to print out the average score. So now that's all the code that's within the function. Now to call the function and actually see what it does, we're gonna like, you're not gonna be indebted anymore. You're gonna move into the main, and that's where you're gonna call the function. So you just do score underscore average, just the name of the function, and then in between those parentheses, you input whatever three values you want to do to replace score 1, score 2, and score 3. So we could do like any three numbers for the scores. And then once we run that, we can see that it just outputs the average score values because we're taking 22 and that's being replaced with score 1. So if you look back into the function, we have 22 is score 1, 33 is score 2, and then 55 is score 3. And then we look back into the code of the function, we're adding 22, 33, and 55 together because we're adding score 1, score 2, and score 3 together. And then just the same thing when we're solving for the average. Once we have that, we have the total score, and then we're dividing that, and then that gives us the average.
All
If you
right,
guys have
that
any more questions about, yeah, functions, and just drop them
yeah.
in the chat and we'll keep answering them. And then if not, we'll just move on to libraries.
Yeah, that was nicely explained by Aveen. And we're almost done. We're on our last two sections, so we can pull through this. Um, let's move on to section 7. If you guys still have questions, leave them in the chat. Section 7 is something called libraries. A library is like a toolbox. So it has a bunch of little tools in it that we can use. And these are tools that someone else has already built. And by tools, I mean anything from functions to variables. It has a lot of things already incorporated in it that people have already built outside of their time. And we can go ahead and import these libraries and use their functions. So Instead of writing everything from scratch, you can actually just import other people's libraries and use their functions. So the basic pattern of this is import library underscore name. So library underscore name will obviously be replaced by whatever the name of the library you want to import is. But the basic notation is import library name. So before you reference any of the functions or the tools of libraries, you have to import the library into your code. So make sure you have that statement. And then you can use any of its functions. So here's a quick example. Look, see here, we have imported the library math. So math is a very basic, very common library that's acting made by the developers of Python, but you can import the library and use some of its cool functions. So as you can see, this statement imports the library, and then here we are using some of the functions. So we have math dot square root of 16 and math dot pi. So let's see why this would be used. Let's say I want to find the square root of a number. It's pretty hard to do that without having this simple square root function. The math makes it super easy to get the square root of the number in one line. So basically, this square or sqrt function stands for square root is provided from the math library. So to reference the functions or the tools of a library, make sure you put the name of the library, period, and then whatever you want to access from there. Because Python needs to know that you're gonna get whatever you're gonna put from math and not somewhere else. So here's an example. Let's say I want the value of pi. You guys probably know pi is a never-ending number. So are you gonna sit there finding the numbers of pi and then typing it over and over and over again? Probably not. You can always write 3.14, but if you want to be more precise and use actual value of pi, just use math.pi. It gives you the value of pi, as you can see down here. So when I run this, you'll see print the square root of 16 is 4, and print math.pi is 3.1415926, etc., etc., etc. So just know that libraries are toolboxes that you can get tools from. And in I will show you guys these specific libraries that we are going to be using. So we have NumPy. NumPy helps us work with big arrays of numbers. In AI, there's a lot of numbers, a lot of math. And if you guys aren't familiar with arrays yet, the next section is arrays. So just know that NumPy lets you manipulate data. Pandas helps us organize our data. So we can't just throw in data and expect the code to find where is what on its own. So we use pandas to go ahead and organize data like spreadsheets, make it nice and easy for our code to run. TensorFlow PyTorch allows us to build AI models, and my favorite personally, scikit-learn, gives us the tools to apply machine learning models to our code. So it basically is the life of the program. Without these libraries, it would be really, really hard to make AI code. Really, really hard. So these libraries make it easy for us. And once we start with our linear regression, which is the next class, you will see these libraries in action. So just have a general idea that these libraries exist. This is what they do. And yeah, so those are libraries. They're super helpful in AI. Moving on to section 8, arrays, our last section.
Okay, so our last section, we're almost done. So arrays, they look a lot like lists, but we just use it for more numbers and larger data sets in math and science. So in AI, we're gonna often deal with like thousands of like numbers, and arrays help us make it like more efficient because they're more powerful and they can do math on all these numbers at once. So in Python, we use just we were talking about earlier, we use lists for basics. But then when we're using more AI Python, we're gonna be using um we're gonna be using arrays. So if we look at our example here, we have the first big thing is just a list, simple, like we just talked about. It's just a list of numbers, 1, 2, 3, and 4. So when we run it, we see that it outputs just simply, just like we were talking about earlier. It's just a list values. And then so we move on to the libraries, just like we were talking about earlier, just like Depshi was saying, we're importing the NumPy library, which is something new. So we're just gonna be we just use it because it helps us work with the big groups of numbers more efficiently. And then it's really similar to a list, honestly. We're just defining an array with those same values, 1, 2, 3, and 4. And when we're printing it out, we can see, like looking at the output, it outputs the same thing. It's just 1, 2, 3, and 4. It's really similar to lists. It's just that lists are fine for smaller tasks. We just use arrays because they're smarter and they're a lot faster for bigger data. And We can look at our second example here too. With arrays, we can do math on whole lists at once. Instead of having to iterate through a list and like loop through each of those values, just like Devshi was talking about earlier, we can just do it on all of them all at the same time using an array. So in our example here, we're defining an array with 1, 2, 3, and 4, and then we're printing out an array times 2. So simply, it's just multiplying each of those values in the array times 2. So we can see our output is just 2, 4, 6, and 8. Yeah, that's basically, it's all about array. You don't, it might be a little bit confusing, but it's simply, that's just the overall understanding that you guys need to get. It's just really, we just really use it in AI to help us with those like really large data sets, and it makes it a lot faster and it's much more efficient.
Yeah, that's a great explanation. Just think of arrays as smarter lists, like she said. That should be enough understanding for now. If you don't understand libraries and arrays, we can work with you in a little bit after class to get that going. But I hope you guys got the general gist of Python. We do have a couple of things to go over right before you guys leave. And if it's possible at the end, I would request all of you guys turn on your cameras if it's possible for you guys, so we can have a little picture of all of us together. So we'll do that at the end of the class. So if you're comfortable with it, no pressure, no nothing. Um, but yeah, let's go over some of our last points and we will conclude the workshop.
Okay, yeah, just some important announcements we have before ending today's workshop is so okay, yeah. So our first class is next Saturday on September 6th from 8 to 10 a.m. That's our first official class. We're going to be actually going over the Python. We're going to be officially going over those like AI concepts. So hopefully you guys got a good understanding of Python today. If you haven't, feel free. We're going to be posting the video recording. We're going to be posting the notebook and the slides. You guys can look back at it anytime. And you guys can feel free to ask us questions as well. So we can make sure you guys have like a really good understanding. And then we can jump into AI and like get kickstarted with that because that's what you guys are here for. And so yeah, just make sure you're watching out on the Google Classroom for there'll be materials will be posted on there and updates will be posted as well. So yeah, make sure you're checking your email and the Google Classroom. Make sure to follow our Instagram and TikTok at UXAI so you guys can also stay updated there. We always post funny reels and yeah, just really be part of our community. And something to look forward to is on September 13th, our class that day, we're going to be hosting an interview with a Princeton researcher and AI startup founder. We were talking about how we're also going to have like opportunities for you guys to talk to these people. So that's going to be one of those days you guys can ask him questions and we're going to be doing an interview so you guys can really take use of that opportunity. And yeah, once again, thank you guys so much for joining today. If you guys have any questions, then let us know.